everybody. Hello from your favorite artist, electronist, Mr. Q12 here. Someone from Facebook groups wanted to make soft start, but with PWM driving. And he also put this chip name, this TL494 that you are seeing it here. Let me unveil this because I rewired everything to be normal, like the real chip is. So I rewired it for myself to make it easy for me to work with it. So that's why it is covered here. And you can see the links. It's only the wires are rewired. The original chip that is there is rewired here. And these are the actual pins. And what I did here, I actually put a resistor and I made it 1 milliohm, 1000th part of a single ohm. So it's like a wire pretty much, what I put there, that resistance. This is actually a resistor, but I made it very, very thin just to be able to connect everything, to make new pins pretty much. That's what you are seeing here. So this guy is presenting me this very new chip to me, and I got intrigued because of it, and I started to look on internet to see what other circuits are like, and I built a couple of them actually. This soft start, this is the circuit that this guy built it originally, and I simulated here, and is not really doing anything. Let me actually show you how it's working in this configuration, which is bad in my opinion, but probably it's simulator bad, but it is reality good. It might be like that. So I got these spikes. Only single spikes when this potentiometer is almost at its maximum here, and I'm getting these spikes, and believe it or not, it is working with those spikes. I believe this motor was turning a little bit. What I'm collecting here on this oscilloscope, I'm collecting the signal that is going into that transistor. But this is his circuit, and it was creating those spikes. So I got mad, and I searched myself. So this is, in my opinion, this is not good. It's doing something, but not really. It's this guy circuit that he find it. And then I find it on YouTube, actually, this circuit that we are seeing here. And let me run it for you. Let me close that. Let's open the second one here. So this is perfect, actually. And this helped me a lot, this circuit, especially here on the test pins, pin 3 and pin 4, to add this potentiometer here. And let me actually close it because I want to show you that this is another potentiometer, but this is how you connected them. And this in the middle is not connected to that, is going directly to the 12 volts there on pin 8 in this case, to the output. This pin 8 is the output, and pin 11, I believe it was, also is with 1 kilo to the positive, is keep high, pull up resistor, this is called, and this one as well for pin 11 here. These are the two outputs. You can follow the oscilloscope rails. You see it is going to this output 2, and this one here is going to this output 1. So these are the two outputs of this chip. By the way, this is a very new chip for me. I don't have it in my arsenal. I only was curious how it's working and how to work with it, but I'm not an expert on it either. But I managed to make it work, so that's cool. That's very cool. From what I understand, this chip is used, if I understood it right, is used for on the boards of electrical tools like a screwdriver tool, pick hammer, I don't know, working tools like that, for the trigger circuit, if I understood it right. Let me actually protect this 1 mega here, because once I set it on 98, I don't change it at all after that. So I'm covering it like this to remind myself not to touch it, and only change this 10 kilo potentiometer that I'm having here. So let's run it right now. And if I'm changing from here, you see there is changing. So you see, I spend a ton of time to understand pin 13 and pin 14, what they are doing. And basically this is what they are doing. Pin 13, if it's connected to ground, at least here in the simulator, I'm not sure in reality if it's the same, because that movie from YouTube, that guy, this pin 13, he was leaving it in air by disconnecting it from pin 14. So these two pins were connected. But in my version here, it is working like this very well, actually. When I'm grounding pin 13, is making the two outputs, square waves are in phase pretty much. And when I'm clicking here, when I'm disconnecting this pin 13 from the ground, the square waves are not in phase, unphased, right? So this took me quite a couple of hours until I realized how to properly link it. I didn't read all the datasheet, unfortunately, and probably there is some mentioning there, but I had to do it the hard way. And here, only one output, this pin 11 output, is connected to this circuit. This is the after circuit, and I believe this motor was turning, but now is not. Yeah, it's very, very slowly. It's turning, like you have to wait it. I'm not completely sure why it's working like you see it. It moved a little bit. I'm not sure why it's moving so slowly. It should move a little bit more faster than this. There are some settings that I didn't care about, but it is moving very slowly, very shitty, but it is doing it. All right, so this is the second one. This is actually the third one. When I actually opened the Texas Instruments datasheet for this specific IC, this is exactly the same circuit that I took it from here, and I copied here, and I put it to work. So let me actually make it work. Let me close this. This is number 3. what we are simulating. So 1, 2, 3. You see, this is the third one which we are having it here, and it's showing these two lines because it's not connected. You see here when I'm connecting it there, it is showing that it's working. You see when disconnect. So it is the oscillogram for this particular circuit. If you see here in the Texas Instrument in this datasheet, pin 3 and pin 4, it says only test inputs. What the fuck is those test inputs should look like? And pin 3 and pin 4. And I tried a lot of stuff, and it turns out this guy from YouTube did it by itself and did it well, because only this thing is working so far. Again, I'm not an expert, but it's working very good actually with his setup. And check this out. You see how it's 10, 11, let's see, like that. 13, 14% here. And when I'm moving it here on the other side, you see, 86 and 87, that's it. It's full 100%. 99% duty cycle, pretty much. So it's not on the margins 0 and 100 for this potentiometer. It's a little bit less, like 80 and 10. And let me uncover this little thing. It's the same as before. This is at 97 here. It's not really, but I am covering it to not put my hands on it. I also leave a written text here, but I know I'm stupid. I'm not reading it that often. So the safe way is to cover it. And that's it. It's running actually very good. Let me play it again and show you this little thing as well. Is unphased, and this is in phase. So this is better. This circuit that I copied from Texas Instrument, it is a little bit better than the one from the guy from YouTube that worked. That also worked, but the potentiometer was not really calibrated. That's it for this guy here. Let's run this last one. And open the fourth one, and let's check if it is indeed the fourth one. Yep. You see? And this was the actual request. This was the actual problem from that guy. He wanted to make specific this IC to make it do its PWM plus the soft start. So I copied, I took the exact same this circuit here from the datasheet. And when I'm scrolling down, let's see, here, you see, this is the title, soft start and dead time. Yeah. And here is also says figure 10.5 soft start circuit. So and it's also looking showing some stuff. But it's showing me this on pin 14 and on pin 4. And on pin 7, so these 3 pins, and it doesn't give me any data on these 2 resistors. It is only showing me that a resistor ratio of 1 to 10 for R6 and R7. So this is R6, and probably this is R7. And also it's mentioning here, this should be at around this value, 2.5 microfarads, this capacitor here. And I took all these hints from here, and I built exactly this circuit that you're seeing it here. I built it here, and it didn't work at all. And I said, well, how the fuck to make it work? And then I built on top of what it was working already. And I've added this capacitor here and this resistor here. This is a bleeding resistor of 100K. You can make it even less, I suppose. This resistor 100K that you're seeing here, connected to ground as you can see, but I put it there to bleed out this 1 microfarad capacitor. It's working a tiny little bit better with this one in the circuit. If in reality is giving some shit, well, don't put it or put a bigger value or play with this value. And this is my experimental circuit that I'm building here. Again, I don't have this specific IC in my arsenal. I didn't build it on breadboard or on the test board there. I'm just helping a guy, and I'm also curious in the same time about it, what it's doing and how to make it work. And I managed to make it work. And let me actually show you. So when I'm shutting off the power for the entire circuit, and when I'm powering it, is jumping to the positive rail, and then it's starting slowly. This, you see how it is getting to the setup value of this potentiometer, of this 10 kilo potentiometer. So let me put it here on the middle, and when I'm opening the circuit and closing it again, you see how they moved. This is the 0 volts, and when I'm pressing here, it will jump to maximum to supply voltage there, and then it will start PWMing very slowly actually. Until it's reaching this setup that I'm from the potentiometer. And if I'm changing here, it is also moving slowly, you see, because of this capacitor. And here, the same. If you remember, or let me do this little thing. I'm cutting this line here for you to see how fast it's moving. You see, it's almost instantaneous, maybe with a tiny little bit of delay, but in reality, it will not be visible, this kind of delay. But it is moving very, well, instantaneous, almost instantaneous. So that's the role of this capacitor. This is what it's doing. Is slowing down. You see, and is and now and a little bit more and 0. Let's see. Beep, beep. Yeah, it's quite cool. You see, and of course, if I'm adding a bigger value of this capacitor, like 10 microfarads, it will move even slower. Let me actually show you. Let's see how slow it will work actually. Unfortunately, when I'm starting the simulator, it's doing that. So now, we have to wait here until it will. Yeah, starting. You see how very slow. So this is, I believe this is the setting, I guess. Let's change it a little bit. Are you changing? You should change. Look. Yeah, it is very slowly, super slow. You see this here is getting less and less, shorter and shorter. Yeah, but very slow, super slow. So that's what this capacitor is doing, is delaying quite a bit. Okay, let me stop it and undo back to 1 micro because that was before. And pretty much this is it. This option here is important to have, probably, on this delaying and this soft starting of everything. And it's quite interesting. I don't like this that is jumping directly to positive rail when it's switched. But probably doesn't matter. I was thinking to add an inverter here, an inverter gate, and to switch it to 0 volts. But when it's off here, it will stay on there, and when I'm connecting it here, it will go down to 0 volts, and then will start to rise up, and also invert the PWM that is this chip is providing. So again, this is having 2 outputs, output 2 here and output 1 here. I'm not completely sure how to use it more with both these outputs. I'm only checking them with this oscilloscope that you're seeing here, but other than that, I don't know how to use it for other stuff or other advanced stuff. And also, my advice is to use a 555. Probably a 555 will be a bit more easier to set up than this motherfucker. This is very specialized. I have no idea what it's doing, but the fact is that I did it, that I make it work as it is. This one is very specialized for something that I have no idea yet what is exactly doing or used to do. Probably in industry, in a commercial industry, most probably, and probably for in the industry or army or whatever, because of these 2 outputs. This is a very special chip. I stayed entire project, all these circuit diagrams that you are seeing here, these versions, I stayed 1 day from when I wake up until I am going to sleep, probably with a small little pause right now, but literally 1 day I spent on it. So I am very tired from this one. I also built the 555 version of the circuit, but is not really doing that great. You see here the maximum on output 1, which is here. Actually, this node here, this is the output 1, is 10 volts, and this circuit is powered with 15 volts. So it's cutting the voltage here. And on output 2, which is here, is 7.7 volts. And it is doing something weird. It is kind of ramping, but it's weird shit. And also the configuration is not using the output of the 555 at all. Actually, you can see here 1 bad connection is referring to that output that is not connected to anything. That's the bad connection. And yeah, it's very weird setup. And this is a thing that I find it on internet. It is working. It is working absolutely fine, actually, absolutely fine without this circuit. So only this circuit until this diode is working by itself, excellent. But when I'm attaching something to it, is going to shit. By the way, this diode doesn't matter how you pointed it towards there and towards there. There is the same output too, and the same output 1 is really, I put it there to not to get the pulsing from here, not to get it into this circuit here, and that's what protecting that diode there. But it is working, but it's a very strange circuit with the 555. I didn't find something better than this. It's not made for pulsing. This is a soft start with a MOSFET, and adding these 2 capacitors here and only 1 resistor here on the gate, and that's it. This is very cool. A very nice soft start, but only for constant current, not pulsed. Whatever the pulse is, square wave, triangular wave, or sinusoidal wave, whatever the pulse. But this is constant current. Is doing this very slow curving. You see, here. And it's reaching this maximum voltage of 9.44 from 12 volts. So it's a little bit less. I'm not sure why. Yeah, on this output here. And here is a load of 20 ohms. I copy it as I find it on internet, but I'm showing you these versions that I tried. All right. This IC that I'm having here is used where is needed 2 outputs, 2 PWM outputs, either synchronous or asynchronous. In synchronization like this, when they are the same, both of them, or 180 degrees complementar. From what I understood, from what I've read about it, it is mostly used in converters, H-bridge converters, also switch mode power supplies, or DC to DC converter like that. Mostly used in a push-pull configuration for DC to DC converters or inverters. So as an example or operation, in a push-pull converter, each PWM output drives a separate switch, such as a MOSFET or BJT, and these switches alternate, enabling the efficient transfer of power with high stability. Push-pull converters offer improved power handling and efficiency. Half-bridge converters. The two outputs drive the switches alternately, ensuring that one transistor is on while the other is off, allowing for the control of power flow to the load. This configuration is efficient and used in applications like power supplies for audio amplifiers or motor drives. It's a very interesting chip, but in my projects, I never need this kind of configuration, this kind of PWM configuration that we are seeing here, especially this complementary operation when one is off and one is on PWM. In another application, you have two separate PWM channels. Each PWM output can control different loads or switching circuits independently, making it useful for application like controlling two motors or two different power rails in power supplies. Yeah, I never had this issue before. This is a very interesting and very new functionality for me, and very new integrated circuit also. I never seen this thing before. Also in buck or boost converters with multiple outputs, the two PWM outputs can be used to control multiple buck or boost converters in a power supply with different output voltages. Switch mode power supplies, SMPS, is commonly the two PWM outputs can be used in either push-pull or half-bridge configuration to drive the power transistors that switch the transformer in the switch mode power supply. SMPS. Yeah, it's a very interesting chip, and I don't really feel the need for it to have it, but probably in the future I will take it into my arsenal, most probably. But until then, it's just a curiosity for me at least, and I'm very proud that I made it work. Yeah, it was a novelty for me. It was something new, and I'm like a fly. I'm going directly to the light and burn my wings into it. All right, that's it for this part. Thank you very much. I hope you like it. And that's it. This is it. This is all that I wanted to show you. All right. I hope you like it. And leave a like also. Don't be a motherfucker. All right. Bye bye. From your favorite artist electronics, Mr. Q12.